Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn how to solve linear inequalities. Now, solving a linear inequality is really similar to solving a linear equation with a couple of differences. The major difference is that if we divide both sides of an inequality by a negative number, or multiply both sides by a negative number, the direction of the inequality sign has to reverse. Another difference is the way that we present our solutions. So we're going to use set builder notation, we're going to use interval notation, and we're going to show our solutions on a number line. We won't do that for all of them, but those are the different ways that you could be asked to display your solutions. All right, let's begin with the first one. I've got 3x minus 10 is less than 8. And I want to think about what I would do if I had 3x minus 10 is equal to 8, and then I'll do the same thing here. I'm going to add 10 to both sides of the inequality to isolate the variable term. So now I've got 3x is less than 18, and I can divide both sides by positive 3 to get my solution of x is less than 6. Now, one way that we can show our solutions is in set builder notation, and that would be the set of all x such that x is less than 6. Next, I like to do the number line. If I need interval notation, I'd like to begin with the number line. So on a number line, got arrows on both sides. I put 0 in the center, and I think about where would 6 be. 6 is to the right of that. And you can put all the little marks if you want, but just showing me that it's to the right of that's good enough for me. I'm looking for x to be less than 6. So it's not including 6. It's only the values that are to the left of 6 on the number line. So what we do is we'll put an open parentheses, a right-hand parentheses at 6, and then we shade to the left from there. In interval notation, I can read that off the number line. I write this as parentheses, negative infinity, comma, 6 parentheses. The right-hand side is 6. It's not included, so I use the parentheses there. On the left-hand side, because that left-hand arrow is included, that means that the values decrease without bound, and we write that symbol, negative infinity, to indicate that. And that's not a stopping point where it ends, so we always use parentheses when we use infinity. If the right arrow had been shaded, the right-hand side would be positive infinity. All right. Let's try another one. This one will bring up the issue of having to divide both sides by a negative number. First step is to subtract 7 from both sides to isolate the variable term. Negative 2x is less than or equal to 10. Now, when I divide the left side and the right side by negative 2, I have to change the sign from less than or equal to greater than or equal to. Right. Dividing by a negative number reverses how they compare to each other. Negative, opposite, it switches the relation. So now I have x is greater than or equal to negative 5. And I'll start with the set builder notation, the set of x such that x is greater than or equal to negative 5. We could also say that x is at least negative 5. On the number line, 0, negative 5 is to the left of that. And this time we want x to be larger than negative 5, so we're going to shade to the right. But because of the equal sign under the greater than sign, that means that negative 5 is a solution. We indicate that with a square bracket, and then we shade to the right. Interval notation would look like this: negative 5 with a bracket, comma, infinity. Again, the right arrow heading towards infinity. I do think that doing the number line first will really help you with your interval notation, because then you can read it left to right off of the number line. Okay. This problem has a little bit more to it, but it's just like a linear equation. We'll begin by distributing the 2. 9x minus 11 is greater than or equal to 2x plus 10. Now, when we were solving linear equations, I suggested that you try to move x terms to where they would have a positive coefficient. With inequalities, I'm going to reverse that. I always want to see the variable on the left-hand side, even if I have to divide by a negative coefficient. Here, it's not a problem. Subtract 2x from both sides. 7x minus 11 is greater than or equal to 10. Add the 11 to both sides. 7x is greater than or equal to 21. Divide both sides by positive 7. I don't have to worry about changing the direction of the sign. X is greater than or equal to 3. So set builder notation, the set of all x, such that x is greater than or equal to 3. On a number line, 3 is to the right of 0. We're shading to the right. We're including 3 as a solution because of the equal sign. So a square bracket at 3, shade to the right. By the way, that square bracket or the parentheses, that should always open in the direction that you're shading. So because we were shading to the right, I want the bracket opening to the right as well. Finally, interval notation, left to right, bracket 3, comma, infinity. All right, one more to do here, and this gets to that difference I was mentioning earlier. If this was a linear equation, I would subtract 2x from both sides because that would give me a positive coefficient of x on the right-hand side. But the reason that we want to collect our x terms on the left-hand side is that it's easier to tell which way to shade on the number line if x comes first, if x is on the left-hand side. So I'm going to subtract 4x from both sides. Negative 2x minus 9 is greater than 21. Add 9 to both sides. Negative 2x is greater than 30. Now I need to divide by negative 2. And when I do that, I'm going to switch the direction of the sign from greater to less than. Divide 30 by negative 2 as well, and I end up with x is less than negative 15. Don't forget to change that sign when you divide by a negative number. Right. Set builder notation, the set of all x, such that x is less than negative 15. On a number line, negative 15 is to the left of 0. It's not included, and we're shading to the left. So parentheses facing left at negative 15, shade to the left. In interval notation, that's negative infinity because of the left arrow being shaded, comma, negative 15, parentheses. The infinities, negative or positive, always gets parentheses. The negative 15 gets parentheses because on the graph we use that, which because there was no equal sign included. All right, those are simple linear inequalities. In the next video, we'll take a look at inequalities that have two parts to them, compound inequalities.